The Sun, The Cool Kid by Ariane Taylor. Why does the sun look yellow to us? Have you ever thought about why the sun looks yellow or orange to us? The sun is a star. The sun emits energy by nuclear fusion from hydrogen turns into helium inside the core. The sun is also known as the yellow dwarf. The sun's composition is about 92% hydrogen and 8% helium. So this is a picture of a galaxy. Um, so it's like a spectrum of different colors of stars that we see. We see green, we see red, orange, yellow, white, blue, etc. So I have a quote for the definition of a galaxy by Hewitt. So a galaxy is a swirl of stars including the sun. Okay, the three star properties. So color. Stars can appear orange, yellow, white, blue, red, and red. Luminosity. Luminosity is the total amount of energy emitted by the star into space, and it is measurable. Brightness. How bright the star appears. My picture for this slide is a picture of the Big Dipper. I actually did some constellation finding not too long ago, maybe last month, using my phone and a Sky Maps app to help me find the constellations. And I could not find the Big Dipper. I knew where it was, but I could not take a picture of it, or I could not clearly see it. To find the Big Dipper, there is a star called the Polaris, and you can find the Polaris and find the Big Dipper from finding the Polaris star. Did you know that the color of stars reveals its temperature? This is the sun, the cool kid. So star evolution. So the Hertzsprung diagram is the picture that is shown, and it's of all the different types of stars and um, their temperatures and their luminosities. So as the graph goes to the top of the y-axis, that is luminosity increasing, and as it goes to the right at the bottom of x-axis, it's for surface temperature increasing. So the hotter it gets, the more to the right you go, is the hotter the planets get. The more up you go is how much energy the star is emitting. Um, so the phase that the star is in, so supergiant, giant, white dwarf, or main sequence star, the phase that they are in can possibly help scientists figure out how old a star is by its stage that it's in. So the warmer colors to the right of the diagram are the warmer stars. So these are the hot stars. This is actually where the sun is. If you look closely, it's the yellow in the yellow area on the main sequence line, which is like a trend line. And the cooler stars are to the left, and they are higher of luminosity. So these are the blues, the purples, and some of the whites. So let's talk about a main sequence star. A main sequence star generates helium by hydrogen fusion in the core. The sun is a main sequence star. Can you find the sun on the diagram? So as I said on the previous slide, the sun is in the yellow area of the line. So the sun is not harder. The sun is easier to find on this diagram because it only has the main sequence stars, so only the stars that are in the middle. So it's the yellow, it says sun. Okay, so over time the sun will increase in luminosity and decrease in surface temperature, moving towards the left of the HR diagram from its original position. So this is according to Palma, Dr. Palma, and below is a future HR diagram of the sun. So the sun was in the yellow on the main sequence line previously or presently, and in the future it will be more towards the left, which means it will be a little cooler, and the luminosity will increase. Okay, why does the sun appear yellow in conclusion? The sun is a warmer star in temperature. Remember, the star was on the right side of the Hertzsprung diagram. The sun has middle range luminosity and emits more energy as it gets older. So, as I said before, the sun was more towards the bottom on the luminosity axis, and over time the sun will increase higher in luminosity. Lastly, the sun is a main sequence star. So we talked about what a main sequence star was, and here are my sources. Thank you for coming to my TED Talk.